Alrighty, this one's on the extracellular matrix. I still got that funky video quality because of the privacy screen, but that's alright. The functions of the extracellular matrix are providing like a cushioning, kind of keeping things in place where they need to be, preventing bad things like infections and tumors from spreading everywhere. It kind of just, it's like the jelly that, like if you ever see those photos of jello salads that people had and things were just in the jello, it's like that. The major ECM, extracellular matrix proteins, are collagens, elastins, laminins, and integrins. So collagens are the most prominent ones. Collagen type 4 is the most prevalent protein in your body, I believe. Fact check me on everything. I'm just trying to remember what was put in this PowerPoint. Elastin, pretty good because it doesn't really use a lot of energy when it is used, so that just stretches things and goes back in place. So an example would be like your arteries and veins, is your blood vessels need the elasticity for blood moving through it. It also helps, your skin with like rebound. There's a little bit of elasticity to your skin. Laminin. Oh, collagens also have a triple helix structure. I know I keep jumping around. Laminin is a cross-shaped protein, and that does a lot of your, like makes the base for things. So like if you have a cut and you need to start having it clot and build a kind of mesh framework to patch it up, that's going to be your laminin. It's also helps with your skin, so your dermis and your epidermis. Like if I do this to my skin, it's structurally keeping it how it should be. So people that have dysfunctions with their laminin they have a very poor tolerance for friction. So if I did like this, I would get blisters because my skin couldn't handle any amount of tension. Steps of the production of collagen. Collagen's made in the cell and then sent out of the cell, secreted, and then reformed outside the cell. And there you go. That might be oversimplifying it, but I'm trying to get this under like the 8-9 minute cutoff, so we're just gonna speed run it and then I'll double check my answers in another video, possibly. Defects in production of the extracellular matrix. We kind of jumped ahead, but that's fine. Scurvy, OI, and Jeb. Scurvy, I feel like everyone's heard of scurvy. Oh, you need vitamin C to make collagen. That's an important part to that. So scurvy, you don't have enough vitamin C, your collagen's not being made well. It usually means your gums start like coming away from your teeth, there's a lot of bleeding. And then you can get that from citrus. So eat citrus, get vitamin C, prevent scurvy. Life advice. OI is osseous incomplete, imperfect, something in Latin that means something's wrong with your bones. Basically, it's your brittle bones kind of disease where I think it's your laminin. I don't think there's any diseases that we covered with elastin in this unit. But you have brittle bones. It's kind of a self-explanatory bit. And Jeb, I forget what that stands for, but that'll be in the correction unit I'll do, I guess. Then we have glycosaminoglycans, aka GAGs, because that's what their initials are, and proteoglycans, and then describe them, their structure, synthesis, degradation, and defects therein. Okay, so your GAGs when they stretch, the water likes to go there, and then they'll compress and the water will reconfigure itself. Basically it's like they describe it as a bottle brush. So you have your like one skinny thing. So this is gonna be your, not your gag, your other thing, your proteoglycan. So this is your proteoglycan. Your gag would have like all the little brush bristles coming around the top of it. And these are in your cartilage joints to help with pressure. So then they, like, when you put pressure on them, and then they can reform. And it's kind of like the cushioning that was brought up at the beginning. And water really likes the gags because they have a negative charge, and water is a polar molecule, so it gets attracted to the charged areas. Synthesis, you stick the gags on the proteoglycans. The gags are made up of 2 saccharides. They have a disaccharide structure. They also go with, you take a gag and a trisaccharide structure, and they'll bind onto a serine that's part of something, probably your proteoglycan, and then that's how it attaches to your brush handle. Degradation and defects. Okay, so I know that I'm mixing this up with the last part of this, because the last part is the role of MMP and TIMP, which essentially MMP is cleaning up all the ECM proteins, saying like, oh, we have too much collagen or whatever it is, and like kind of chops it up and makes sure there's not too much ECM proteins hanging around. And then the TIMPs are like, hey, what the heck, we need more ECM proteins, and then like making more, and kind of interacts with the MMP. So if you have too much MMP, you're not making enough proteins to balance it out, you start getting things like arthritis. I think that's where I'm going to end it here, and then I'll attempt a corrections video for part 2.